Assalamu alaikum brothers. Let us start with the experiment 1 of the automatic control system part of the electrical testing 3. The first experiment is open loop and closed loop control systems here. We are going to understand the principle of open loop and closed loop control system by considering the room temperature control system. Before starting with our experiment, we need to understand what are the equipments we are going to use in our experiment. If you can see here, we are going to use two main equipments. One is your computer system. The second one is the COM3 master unit here. Okay. In the master unit, if you see here, we have a board connected here. This board is control technology board which has the serial number which is 70082 here. This board is connected to the computer here, so it means we are going to use two things. We are going to use the hardware from the board and we are going to control it using the software which is installed in the computer system here. Now how to access the software? You will see that on the desktop you are going to find this icon here. So whenever we need to start working for the control experiment, we need to switch on this master unit which is on right now, which is showing you, and then we need to start by clicking on this icon here. Now some detailed explanation about what you have on the COM3 board here. If you see here for the master unit, we have basically many things here. Okay, so we are not going to use all of the things. I'm going to explain only the things which we are going to use in our experiment. So first thing is the oscilloscope. So we are going to use an oscilloscope to analyze different waveforms here. If you see here, or if you have worked in the electrical testing 1 and also in the testing 2, you know that we are going to have two channels in the oscilloscope. So this is what we have, like we have Y1 as first channel and Y2 as the second channel, and COM is the ground here. Okay, so whatever output we need to see or we want to view, we can connect it in Y1 and Y2 to view it, okay, using the software. Second thing is about the multimeters. You can see you are given two multimeters here. So most probably we are going to use one multimeter at one time here. So what is the multimeter? We can measure the voltage, we can measure the current, we can measure the resistance here. Okay, and normally we are going to measure the voltage for this particular course here. The next thing which we will be using is the function generator. Now function generator is a device which can generate the signals of different types here. So for our course, mostly we are going to generate or we are going to produce the voltages, which is the DC voltages from here. How to change this value? You can you can move this one in the clockwise direction or in the anti-clockwise direction to increase or decrease the value from the function generator here. We can also control these values of the function generator using the software, which I will show you. Next thing here is, if you see here, this is a COM3 board here. Okay, so we are not going to use all the things in the board here. For example, in the first experiment, we are going to deal with this part here. Okay, this part along with this fan here. Similarly, we are going to use the PT1 and PT2 systems, and also for the integration, whenever we are going to use the integral functions here, we are going to use here. It means you can give the input here, you can take the output from here. Next thing is, since we are doing the experiments of the control system, so obviously we are going to study about the PID controllers here. So whenever we are going to work with the P controller only, then we will make this one on and we are going to keep the others off. So depending upon which particular controller you are working with, we can make it on and off from here. Okay, this details like what should be on and which should be off will be clearly given to you in the procedure of the experiment. Next thing is about the KP here, gain. So either we are going to use 1, sometime we are going to use 10, sometime we will be using 50, so we can change it from here. Okay, so I think this is the introduction about the board here. So now what are the steps to start with? First of all, what I told you, the first step will be on the desktop you will find a icon which is basically this control icon here. So you need to double click this one, making sure that you have already switched on the master unit. If your master unit is off and you switch on this control, you switch on this or you double click on this icon, what will happen? You will get a notice like this, like the master unit has been turned off. So what you will do, basically you will close this window, in fact all the software, you will turn on the master unit again and you will start from here. Okay, so if your master unit is on and you double click on this icon, the next step is you are going to get a window like this. So it's up to you, you can enter any name here. Okay, just for example we have given 1 2 3 4 and just press continue here. So you can write anything here. Okay, it doesn't matter. So just when you press enter, you will come up to this screen. When you press enter to this screen, what will happen? You will come up with some screen like this here. Okay, now right now it is open loop control system here, but it does not mean you will get this one. It depends upon which particular experiment is selected there. Maybe that page will open for you. So what we have, all the description about the experiment which is given here, we have also included it in your manual here. So you can use the theoretical knowledge background, you can read it and you can understand before doing the experiment here. Now, what I need to explain here is, first of all, if you see here, we have two panels here. One panel is here and the second panel is here. Okay. What we are going to use here, the things which we are going to use here means this is your function generator, which I have shown you there. We can control the function generator from the master unit, or you can simply click on this icon and you are going to have the software function generator here. You can select any waveform, you can give any value from here. Okay, the next thing which we are going to use is the oscilloscope. So whenever you put something in Y1 or Y2 channel here, you can view the waveforms by clicking on the oscilloscope here. The next one is, if you see here, this is basically your multimeter here. So if you click or if you place even the mouse on it, it will show you which particular icon, this one. So just click it, you will get the value directly on your software here. Similarly, if you want to plot some curves or some graphs, you can use the characteristic plotter here. Similarly, this will be for the response. So these are the 5 icons which we are going to use in our control system experiments here. Next thing what we have on this side, simply this is a menu. Whenever you click here, it will give you the list of experiments like this. Okay, when you click here, what will have, you will have a list of experiments here. So depending upon which particular experiment you are doing, you can click it here. Okay, just click it, it will tell you okay how to move like. Then you will have this one, you can press this one, it will go page by page. But if you want to jump, you can use this one, it will jump like maybe from one topic to another topic, it will go faster from here. Okay, so depend. Normally we prefer this one once we are in the experiment. Okay, sometime if you start here, you can refresh this one, so all the setting will be refreshed for you. Okay, so right now let's suppose we have started with the open loop control system. When I press it, I'm going to come to this screen here. Okay, so this screen already everything is given in the manual. Please go through the manual for the detailed explanation about the control systems here. What I will do, I will just give you just general overview of the basic principle here. So what we have, this is a basically room temperature control system here. Okay, with disturbance and without disturbance here. So now what we have, simple, we have few things here. First of all, to monitor the outside temperature, we are going to have a temperature system here. Okay, so we have a thermometer here which is going to record a temperature in some degrees, and as you know, this is a control system, so it need electrical signals to work. So the job of this system is to convert from basically your temperature into the electrical voltages or electrical signals, so that the control unit can work on this one. The second thing is we have a control unit here. Now what the control unit will do, control unit will basically control this actuator here. Okay, control unit determines the right opening position for the actuating valve. So basically in this actuator we have two things here. We have basically a positioning motor and the valve itself, means I need to control the opening of the valve to allow heat or the hot water to flow in this heating unit here. Okay, so how we are going to control this one? By some motor, and how we control the motor by using the control unit here. The next thing is this like we have another system here, which is basically the room along with the heating unit here. Okay, so basically what we have, this room temperature, like this heating unit will try to achieve our desired value of the heat inside the room here, and this will be the output of my entire open loop system here. Okay, now for example, in my room I have a window here, and it is a winter season. For example, I have enough heat here, so my temperature is, for example, I say that let's try to keep it around 30 degrees, for example. Okay, so if I open a window during the winter, what will happen? Some undesired disturbance will come from here, so obviously my inside temperature is going to be changed. So for that I need more heat or something, so that it keeps on my desired values here. Okay, so this is the basic working principle of the room temperature system. Okay, this is what we are going to see in our experiment. Now what we have, when you come to the experiment here, basically everything or procedure is given to you. What he said, that basically the temperature control system of the COM3 unit, it has some Darlington transistor which is controlled using some voltage on the board socket Y of t. So it means this is on this part, this is basically your Y of t, this is your X of t. So this is, for example, my transistor, and I'm going to control this transistor by giving some voltage in Y of t. Okay, also my sensor which I'm using is KTY10 here. Now what we have, we need to, before starting with the open loop experiment, we need to calibrate our sensor here. Okay, so temperature system sensor we need to calibrate here. So what we are going to do, first of all, we need to make this connection here. You can see this part basically is this part here. So how we are going to make the connection? By using the wires here. So first of all, simple. We are going to connect the common with some common here. So this is the ground here. So I have connected the ground here. Secondly, you can see here, the 25 is connected with the sense here. So sense is connected with 25, and the output X of t is connected to the voltage here. So this is exactly the same connection on the board here. Okay. So this is the first experiment we are showing like this. For the future experiment, we are going to only use, or we are going to rely on this particular figure here. Okay, it's very easy, just you need to make the wires according to whatever figure you have. Okay, now this is the procedure given to you in the manual. So we have already made the connection. Now he said that with respect to the 25 degree connected here, like we have already connected the 25 degrees in the sense here, record the corresponding output voltage. So for output voltage X of t, what is the output voltage here? So you can see here, when we connect 25 degrees here, the corresponding output voltage is 2.80 here. Okay, so either you can monitor it from the from here, from the COM3 board, or the second thing is you can basically open the software. Like if you see here, if you press an icon or your mouse on this one, it will show you this is your multimeter one. Just click on it, so a multimeter one will be open. You can change the view, how to view this one, by changing the value of D. Okay, so this is 2.0 volts. Similarly, M means like you are changing the mode, either you are looking for the current here, so then you can change from M. Like right now we are using the voltage here, so that's why we have V here. Similarly, for resistor, you can change from here to view the required resistance. Okay. Next thing is, if you see the procedure here, first we find we're using the 25 degrees, which was basically 2.80. Now we change it to 100 degrees here. Okay, so just change it to 100 degree. The voltage equivalent is 9.80. Okay. Similarly, now what we need to do here, we need to use a characteristic plotter here. This is a characteristic plotter here, because we basically want a temperature of the voltage which is equivalent to 60 degrees centigrade here. Okay, so right now for 25 we know that the temperature is 2.8. For 100 the temperature is 9.8. Like, you can manually write it here. So whenever you press the show button here, it will show you a graph here. Okay, next thing is, you can see here we have this red line here. So just put a mouse on it and click the mouse or hold the mouse button. So you can basically, you can move the cursor around here. So basically we move a cursor so that the input voltage becomes something close to 60 degrees here. Why 60 degrees? Because we want the output voltage corresponding to 60 degrees here. So when you press it here, like for example, it becomes close to 60 degrees, the output is 6.07 or something. Okay, so it will vary. Okay, maybe like for example, this is 6.07. Maybe in some system you will get 6.2, 6.14. So from system to system it varies here. Okay, so let's assume we say that the value here is 6.1 here. Okay, so just to make it almost similar, so let's suppose you can write the value 6.1 at 60 degrees centigrade. So we have calibrated our sensor here, and we are going to use the same value at 60 degree, which is equal to 6.1, 6.2, whatever value you have, and we are going to use the same value for both open loop system and the closed loop systems here. Okay, now this is the result form here, like in your, which is given to you in the manual here basically. So you can see here for the cell 25 degree what is the corresponding voltage, for 100 degree what is the corresponding voltage. If you want, you can use theta equal to 60 degree, what is the corresponding voltage. Then you can plot the graph here. Okay, same here, you can have the temperature in degrees here, and you can have the voltages along y-axis here. Okay, but remember, whenever you plot a graph in our control system experiment, remember we are going to be strict, like it should be a proper graph. Like, you need to verify, you need to write what are your x-axis, what is the y-axis, and you need to give a scale, like one small box equal to how many, one small box along x-axis equal to how much, how many degrees or something like this. Similarly for the y-axis. Okay, so you need to give a proper scale here and then plot it properly. Okay, if you don't give a scale, if you don't plot properly, then you are going to lose n degrees for it. Okay, brothers. So now let's move to the open loop control system here. So what we have, we have updated our system here, like the graph here, the what you can see from 100. Now we have make it theta here. Okay, and we know that the theta value here we already adjusted it to 60 degrees centigrade here. Secondly, the output x of t is going to here, and now this input here y of t, we are going to control this transistor by using the function generator. Some voltage will be provided here. What we need basically here, we are going to start by giving the value of the function generator or the value of voltage as 2 degrees centigrade here, sorry, at 2 volt here. So we will first give 2 volt here, and what we will want here basically, we want the value which is basically 6.07 or 6.1, which is equal to 60 degrees centigrade here. So basically at the output, we want to bring the voltage equivalent to 60 degrees by controlling the value of the function generator here. Okay, so the step is, we start with the 2. When we give 2 here, it will start increasing the value from here. So we need to wait at least for 1 minute or something so that it stops changing the value here. Okay, normally what will happen in most cases, it will go to some higher value then start decreasing. So we are going to consider the higher value here. Okay, so if you don't get 6 here, then what we will do, we will increase by 0.2 here. Like me, next time we will make it 2.2. So we are going to have another value here, then we will keep on increasing unless we get something around to 6.1 or something. Okay, brother, so this is the procedure here. So let's suppose this is the values we got here. For example, just I'm showing you, when we make it 2 and start increase it, it stop at some value around 4.67. Okay, again, from one system to another system or from one computer to another computer, these values will change. Okay, so don't worry. So this is like, for example, right now at 2 we get 4.67. We keep on increasing by giving the increment by 2, like 2.2, 2.4, 2.6, unless we got some value equal to 6.1 here. And when we got this value, we got the value when the value of the DC value was equal to 3.4 here. Okay, so when z equal to 0, z equal to 0 means when you don't have any disturbance here, which we don't have right now. What we have, the value of u is 6.14 here. You can also include here another one, that the value of the function generator will be 3.4. So at certain value 3.4, the value of u is 6.14 at the response when we don't have any disturbance here. Okay, next time what we will do, we are going to introduce a disturbance of 5 volt here. How we are going to introduce the disturbance of 5 volt here? Simply in the same connection, keeping the same connection, you need to add one more here. Okay, so when you connect this one with the 5 volt, let me show you here, this one. Okay, so we need to connect this one with the 5 volt. This is your 5 volt. So from here to here, when we connect it, what will happen, this fan will start running here. So when the fan will start running, so we will say, okay, we are having some sort of disturbance here. Okay, so what you will do, we just stay, we don't do anything, we just only connect here and we will wait. This value will start decreasing here. Okay, so just wait unless it stop decreasing. So what happened when we give, or when we connected this thing, what happened, the value from 6.14 comes to 5.11. So you can write 5.11 here. Okay, so this was your open loop control system. So what we learned from open loop control system is basically the response of the system will be very slow, like it will increase or decrease the value very slowly. Secondly, when we have some disturbance here, what will happen, it will deviate. Okay, so it will have like it will be unable to counteract with the external disturbance here. Okay, so this was for the open loop system here. Now we will repeat the same thing for the closed loop system, considering the same value at theta equal to 60 degrees here. Okay, just for the closed loop system, what we have, we are going to have a feedback path, and we have almost the same system here. Okay, the more details for each part is given in the manual. You can go here. Okay, so what we have here, basically inside the room we have a controller here. This is your controller here. The controller is getting two values here. This is your actual value and this is your reference value or setup value, you can say reference variable W. Okay, W means like what desired value you need here. Next thing is we have controller here, which is basically the controller. Then what we have, next time is drive motor. Obviously we are going to drive this motor here. Then we have the actuating valve here. Then we have the heating unit here, and this is the whole room here. Okay, and we are going to have a temperature sensor inside the room here. Okay, so unless we get our desired value, this will like keep on changing here, or it will update accordingly here. Okay, so it is more responsive than the open loop system. Next thing is, for example, this is your window here. If you introduce the disturbance, obviously you are going to have some z value here. Okay, which is shown in your manual. So for the experiment setup is more or less the same, but if you see here, basically we are using an analog controller part here. So this is your reference value W. This is the actual value X here. Okay, so depending upon the actual value, which is feedback here, it is going to calculate or calculate the error and update accordingly the values here. Okay, so we are going to do the same thing here. What we wanted here in the multimeter value, we want to bring a voltage equivalent to 60 degrees centigrade here, which is basically 6.14 or 12 or 6.07, whatever value. Okay, but something, let's suppose 6.1 basically. How we are going to update or get this value? By changing the value of the function generator. Simple. Next thing is we are given here, so you can see we are using basically a P controller here by making it on, and the remaining off, and also the value of KP is 10. So we need to change this one on the board to start working here. Okay, so let's suppose, just to give you an example, when you start the values here, what happened, for example, at 5.5, we have some value around 5.27. Okay, so it means you can understand from here these values are more or lessly matching here. Okay, somehow closer. Like in the previous case, for example, we got 6 at some value around 3.4 maybe, but in this case we are getting almost the similar values more or less. Okay. So it means to get 6.1 here, I'm also going to have some value equal to 6 here, 6 or more. So basically I got 6.12 when my value of the function generator was 6.45 here. Okay, so the value of w is connected with the function generator, so it means it is going to be 6.45 here. Okay, at 60 degrees centigrade, which is equivalent to 6.12 here. Okay, now the next step is, again we will introduce the disturbance here. So by keeping the same control circuit, we are going to connect it with the 5 volt here. Okay, so when we connect the 5 volt here, the motor will start running here, or the fan will start running here basically. So we will wait how much our initial value, which we already adjusted here, is decreased. Okay, we are not going to do anything, we don't change, just simply in the same circuit connect to it 5 volt. So it means we are giving some disturbance here, and this value will start decreasing, which will end up, like in our case, it end up with 5.96 here. Okay, again the system on which we worked, we got this value. If you go to the another computer, maybe these values might change, and it can change also bigger. Okay, so it doesn't matter, don't worry about it. So what you have here, when the disturbance was 0, the value of x was 6.12. When the disturbance was 5 volt, the value was 5.96 here. The value of w was basically 6.45 here. Okay. And what we understand here, if we compare it with the open loop system, you can see here the response of the closed loop control system was faster comparing the open loop. Also, when we introduce some disturbance here, the error, we still got the error. We cannot say there is no error. We had the error, but it was less comparing the open loop systems here. Okay, so this is all about the experiment. Thank you so much. Assalamu alaikum.